All right, so this is really the last example in chapter 6. So this is going to be the last video, the last lecture of chapter 6, I promise. Example 12. So let's do one more binomial example just to make sure we're really okay with this concept. So this example says medical records indicate that 40% of the people have type O positive blood. What is the probability that of the next 7 people donating blood, that A, exactly 4 have type O positive blood, and then we have a part B, and C. Let's just, before we even look at part A, let's examine what type of experiment is taking place here. Again, I'm thinking binomial because there seems to be only 2 possibilities when we look at it this way, right? Because we're only interested in the probability that a person has O positive blood. So think of it as either the person's going to have O positive blood or they're not. They're going to have some other type of blood, right? So there's only 2 categories here, either O positive or not O positive. So there's 2 possible outcomes. And we have N independent trials here because we're going to take 7 people, they're going to donate blood, and they're either going to have O positive or they're not. But the probability that any individual person has O positive blood doesn't depend on the probability that another person has O positive blood. So the probability of a person having O positive blood does not depend on any of these other trials. So we have N independent trials here, in this case 7. And we're considering a success having O positive blood, and the probability of a success is 40% or 0.4, right? If I write 40% as a decimal, it's 0.4. So the probability that a person in general has O positive blood is 0.4. So this to me, and that's the same for every single person. So this to me signifies a binomial experiment. It satisfies the 4 conditions. So now let's go to the question. What is the probability that of the next 7 people donating blood, A, exactly 4 are going to have O positive blood? So we said, okay, there's N independent trials, or 7 people in this case, right, that are going to donate blood. So there's 7 trials. And the probability of being successful or having O positive blood is 0.40. And in part A, we're interested in the probability that the number of successes is equal to 4, exactly 4, right? So we want to know what's the probability that exactly 4 people are going to be successful in having O positive blood. So we can use binom PDF in this case. This is, since we're calculating exact, we're going to use the binomial PDF function, where N is 7, P is 0.40, and S is going to be 4, or X, right? When we go into the calculator uses X. So let me share my calculator. So we're going to do second and then the vars key, and we're going to pull up binom PDF. The number of trials is 7. We said the probability of a success is 0.4. And we're interested in calculating 4 successes. So we said S was 4, but we said the calculator uses X. We're going to paste, calculate. And to 4 places, we get about 0.1935. And we could write that down. So our answer is going to be 0.1935. So now let's look at part B. So part B says, what's the probability that at least 5 people have O positive blood? So the probability of at least 5 successes, right? Now, remember, we don't have a binomial function programmed into the calculator for at least, but we do for at most, right? So we could think of this was similar to the example that we did above with the multiple choice question. At least 5 means 5, 6, or 7, right? Because there's either 0 people out of the 7 are going to have O positive, 1, 2, 3, 4, 5, 6, or 7, right? There's my 7 trials. At least 5 includes 5, 6, and 7, right? At least 5. But remember what I did in the other question, I could look at this from an at most perspective because I don't have an at least function in the calculator for a binomial. But I could take away at most 4 from the total probability. So this would be everything else we could write as at most 4. So to get this answer, I could do 1 minus at most 4 successes. And this is going to be 1 minus the binom CDF, right, for 4. So now we can plug this into the calculator. We're ready to go, right? So let's pull that up. So we're going to start with 1 minus. So 1 minus, and then second VARs, right? You want to pull up the binom CDF. The number of trials is 7. The probability of a success is 0.4. And now since we're doing 1 minus at most 4, we're going to put my X value as 4. And then paste, and then enter. And we get approximately 0.0963 if we go 4 places. So this is going to be 0.0963. So this is the probability that at least 5 people will have O positive blood. So we did 1 minus at most 4 people having O positive. And that's going to leave us with the leftover, which is 5 or more, 5 or 6 or 7. And now we have one more part. We have part C, which says no more than 2 have type O positive. So that's the same thing as saying the probability that at most, right? Because at most is no more than 2. And at most, we have a function, right? Binom CDF. So we could use binom CDF for this one. So we want at most 2, the probability of at most 2 having a type O positive blood type. So back to the calculator, second the VARs key, and we're going to pull up binom CDF. The number of trials is 7. The probability of O positive is still 0.4, but now we want at most 2. So I'm going to change my X value to 2. And we get about 0.4199 if we go 4 places. So that's the probability that no more than 2 have O positive blood type, or the probability that at most 2 have O positive blood. So this really wraps up chapter 6. This was the last binomial example that I have. In the next lecture, we're going to start chapter 7.